Lesson 5, Conditional Statements. Just a note before we start this lesson. This is going to be referring to some examples that we're going to be going through. So to be eligible to vote in Canada, a person must be a Canadian citizen, at least 18 years of age, or on the list of electors. Assume for this lesson, when the phrase Canadian citizen 18 years of age or older is used, the person's name is on the list of electors and would be eligible to vote. Conditional statements. A conditional statement is a statement that is written using if and then. A conditional statement has two parts to it: the hypothesis, the part following the if, and a conclusion, the part following then. A conditional statement, sometimes called an if-then proposition or if-then statement, may be true or false. For example, if a Canadian citizen is 18 years of age or older, then the person is able to vote. Or, if a person lives in Victoria, then the person must have been born in BC. Converse statements. A conditional statement has a converse, which may or may not be true. This occurs when the hypothesis and the conclusion are interchanged. So just taking the two examples from before, if Canadian citizen is able to vote, then the person is 18 years of age or older. Or, if a person was born in BC, then the person must live in Victoria. Let's look at an example. We're going to write the following statement as a conditional statement, really just means adding the if and then, and identify the hypothesis and the conclusion. An acute triangle has three angles that are each less than 90 degrees. So the conditional statement would be if a triangle is acute, then it has three angles that are each less than 90 degrees. Now we're going to write the converse of that conditional statement, and we're going to state whether the converse is true. So now we just switch it around. If a triangle has three angles that are each less than 90 degrees, then it is acute. This statement is true. Biconditional statements. A biconditional statement is a statement in which the conditional statement and its converse are both true. When this occurs, the conditional statement and its converse can be combined in an if and only if statement. For example, a Canadian citizen is allowed to vote if and only if the person is at least 18 years old. Let's look at example 2. A conditional statement and its converse are given. If a triangle is obtuse, then the triangle has one angle between 90 degrees and 180 degrees. And if a triangle has one angle between 90 degrees and 180 degrees, then the triangle is obtuse. Are both of these statements true? Yes, they are. Now we can write a biconditional statement. A triangle is obtuse if and only if one angle is between 90 degrees and 180 degrees. You might have noticed that in this lesson there is going to be a lot of new vocabulary. Bear with us. There is going to be more. Just keep all the different types of statements straight, and you're just manipulating different kinds of sentences. So just keep it going. Here's another one. Inverse statements. The inverse of a conditional statement is formed by negating both the hypothesis and the conclusion of the conditional statement. So if the conditional statement was, if a Canadian citizen is 18 years of age or older, then the person is able to vote. For the inverse, we just place a not in there to negate each part of it, the hypothesis and the conclusion. So the inverse is, if a Canadian citizen is not 18 years of age or older, then the person is not able to vote. Let's just do one more definition before we try an example. This will be the contrapositive statements. The contrapositive of a conditional statement is formed by taking the converse of the conditional statement, that was when we switched our hypothesis and conclusion, and then negating both the hypothesis and conclusion of the converse. For example, if the conditional statement was, if a Canadian citizen is 18 years of age or older, then the person is able to vote. We would then take its converse, switching its hypothesis and conclusion. If a Canadian citizen is able to vote, then the person is 18 years of age or older. Now we negate both of those to come up with the contrapositive. If a Canadian citizen is not able to vote, then the person is not 18 years of age or older. This next example represents a very typical type question that you could get on an assignment or on a test. So example 3. Write the converse, inverse, and the contrapositive of the following conditional statement. If a triangle is obtuse, then the triangle has one angle between 90 degrees and 180 degrees. Remember, the converse is to switch the hypothesis and the conclusion. So it would be, if a triangle has one angle between 90 degrees and 180 degrees, then the triangle is obtuse. The inverse is taking the original conditional statement and negating both the conclusion and the hypothesis. So the inverse would be, if a triangle is not obtuse, then the triangle does not have one angle between 90 degrees and 180 degrees. And finally, the contrapositive is to take the converse and negate it. So we would have, if a triangle does not have one angle between 90 degrees and 180 degrees, then the triangle is not obtuse. Here's another example. Example 4. Considering the following if-then proposition. If x is greater than 2, then x squared is greater than 4. Now I've just made a copy of the graph made with a graphing calculator, just so that we can visualize what we're talking about. So x is greater than 2 is from, if you can see where the cursor is, it's everything to the right of that. And x squared is greater than 4 is going to be the curved part, and it's going to be above the cursor. So is the original proposition true? If not, give a counterexample. Well, this is true. As you can see, as the graph moves from x is greater than 2, it is moving higher than the line, so it is indeed true. Write the converse. Is it true? If not, give a counterexample. Now we have, if x squared is greater than 4, then x is greater than 2. If we move to the left side of the graph, where again the parabola is above the line, where y equals 4, it's also greater than 4 when x is less than negative 2. So this would be false. And we just need to give one counterexample to prove it's false. And we could say that x is equal to negative 3. Now let's write the inverse. Remember, here we are just negating both the hypothesis and the conclusion. Then we want to state whether it's true. If it is not, we give a counterexample. So we would state, if x is not greater than 2, then x squared is not greater than 4. Again, just by looking at our graph, we can see that when x is equal to negative 3, this statement is not true. So x equals negative 3 is a counterexample. The last part is to write the contrapositive. State whether it's true. And if not, we can give a counterexample. If x squared is not greater than 4, then x is not greater than 2. This is true. X can be any number between -2 and 2. Example 5. Consider the following conditional statement. If Peter lives in Saskatchewan, then Peter lives in Regina. We are going to assume that the only Regina is going to be the one in Saskatchewan for this question. For A, is the conditional statement true? No, it's not. Peter could live in another city in Saskatchewan like Prince Albert or Saskatoon. B, write the converse. Is it true? If Peter lives in Regina, then Peter lives in Saskatchewan. Well, this is true because Regina is in Saskatchewan. C, write the inverse. And is it true? So we are just negating the conditional statement. If Peter does not live in Saskatchewan, then Peter does not live in Regina. That's true. Regina's in Saskatchewan. He's not in Saskatchewan, then he can't live in Regina. D, write the contrapositive. Is it true? If Peter does not live in Regina, then Peter does not live in Saskatchewan. Well, this is false, because again, Peter could live in another city in Saskatchewan. Note the following general rule. A conditional statement and its contrapositive are equivalent statements. That means that if the conditional statement is true, and so is the contrapositive. We saw this in example 4. Or, if the conditional statement is false, then so is the contrapositive. And we did see this in example 5. It would be similar with the converse and inverse. They would either both be true or they would both be false.